Hello, everyone, and welcome. This is Professor Thayer with you here today to talk to you about Unix text editors. So let me go ahead and share my screen, and let's get started. So today's lecture is about working with the cluster and Unix. It is the second lecture of a three-part series. And we are going to discuss how to work with the text editors on the cluster. So in our first lecture, we have had a first look at high performance computing here at Wesley University. The HPCC is located on the 5th floor of the Science Tower, which is right beside me here. And you can see it right here. And today we will talk about working on the cluster with the editors, because you may wish to set up some files in order to read and write things. You may want to edit some existing information. You would need to know how to work with files. You'll also need to have a brief understanding of the directory tree, so we'll go over that. We'll also visit some new essential Unix commands, and we'll take a look at some of the popular text editors, Emacs, Pico, and VI. And our third day, we will look at bash scripting and queuing, which will, of course, require you to edit scripts using the text editors that we will talk about today. So then, let's get into working with the cluster with the text editors. The first thing we'll visit is understanding the directory tree. So there's a hierarchy of files on any computer. So if you think about, say, for example, your laptop, in a simple case, assuming you just have one disk on there, it would be pretty easy to understand that all of the information that's stored on your laptop must somehow be inside of that disk. And then you would make some folders, and maybe some folders inside folders, or you have some folders in My Documents, or you have some folders on your desktop. These things are all somehow written into the directory tree. We call the root, which we represent here as the slash. This is considered to be the root directory. That means everything is going to come out of that root directory tree, and it will be stored in something that's contained in that, which gives us this idea that all of these things that are shown here must be somehow inside the root. So for example, you might have applications, library, system, and users. Unix systems and Windows, Mac systems do tend to be more complicated than this, but this just gives you the basic idea and gives you some sense of what is on there. And of course, these would all have some more things in them. The part you're probably the most familiar with is the users section. On your laptop, you are likely to only have a single user, yourself. Maybe you have a shared computer with your family or something like this. But typically there's going to be a very small number of users, whereas on the cluster, as we've talked about before, there tends to be a very large number of users. So this is why we have the users. This may also be referred to as the home directory on HPC. So here we have two users. We have Bob, who has not really done very much work at all. And we have Carol, who looks like she's taking some English and physics class and has written a poem and has some directories for some physics projects here. So you can see that these directories, which are what we colloquially call folders, are inside of the root on the directory tree. And so therefore we could, in theory, map out how each of these is related to all of the other locations on the disk. Here's an abbreviated version of what things look like on the high performance computing cluster here at Wesleyan. We have Home 33, which is going to have a number of users. Here's me and one of my students. There could also be another home. So we have HPC 200 and HPC 199. These have some different directories in them, which have some various files and tests and things on them. We also have MindStore, which is a storage directory. We have some additional disks on the cluster. So what is a path? The path tells where a file, directory, or program is located within the cluster, and this is going to be specified either in relation to your current location or in relation to that root directory. So no two files, directories, or programs can have the same path because all of them are unique, and this is why they would, you can have two files that seem to have the same name, but if they're in different folders, they're in fact actually different because their path is different. And we'll see that the path is technically its complete name on that system. The path is what is going to differentiate between two files with the same name. So you might have a homework one on your desktop, and you could also have a homework one in your math folder, and they would be different because they're in different directories, and so that makes them distinct. The complete name of the file, directory, or program is its path, which contains both its unique name as well as the information about how it is situated within that directory tree. And paths can be expressed either absolutely or locally. The absolute representation represents it with respect to the root, that slash, or if you represent it locally, that means relative to your current location. So you might say it's in the directory above, or it's two directories above where I currently am. So here, let's take an example. So here I've just taken some paths from the images we've just seen. Let's say that we are interested in this test1 directory. We can see that we can trace this through to tell what the complete path for this is. So we begin at root. So notice that we use the slash in multiple locations. So the very first slash is unique because that one represents the root, whereas all of the subsequent ones simply just mean that we're transitioning to a new directory. So here we have the slash for root, then we go to home, then we proceed to HPC 199. This is some user on the cluster. Then we have workspace 2, WKSP2. So that would move us down to this directory. Then we need to go to Emacs, and then we would have test1. So this is the complete name of that. The absolute path always begins at root, so we'll have the slash, which we notice is the slash right here, which, as we've just mentioned, is distinct from all these other slashes. The absolute path, because it is absolute, will work from any location in the directory tree, whereas the local one, if you say the directory above, of course, depends on which directory you're currently in. The absolute path will trace the path from the root to the file, directory, or program. The relation of the directory tree to the path, the relative path. So you can also specify where you wish to go or a particular file and so on using a relative indication of that file. And so in order to do that, we need to take a look at a couple of conventions that we can use in order to change the directory. So CD is going to change the directory, and the ... means to go to the directory above. Recall CD with a single dot means the current working directory. So you wouldn't really want to CD to the current working directory, as that would be pretty redundant, but you may wish to go to the directory above. Now, if you want to go to multiple directories above, you can indicate that using CD and then the ... followed by a slash for however many times. So this will go to 3 directories above. So let's assume we're at home HPC 200, workshop 1 right here, and we want to move to user HPC 199's workshop 2 directory. We could do CD, and then we can do ... which puts us one above. Let's see, so we are starting at workshop 1, we're here, and then we go above 1 directory, so then we'll be in HPC 200. We need to go 1 directory above to get to home, and then we can begin the descent down the tree. So notice then that after you have done the ... then you simply just descend through the tree HPC 199 and then workshop 2 to arrive at our desired location. So use the double dots to ascend the tree and the directory names to descend. We can also use the dot in the paths. The dot may seem counterintuitive at first because it does indicate the current working directory. However, it's useful when you're going to use the CP, the copy command, because it requires a source and a destination. So if you want to say, I want to copy something to here, you can use the dot instead of naming the actual directory. The same thing can be used with the slash if you want to copy something in the current working directory. So if you want to copy something in your current working directory, you can do cp./myfile and then provide the destination. So here's some example. Your user HPC 199 in the home directory. So you're sitting in here and you wish to copy file 1, a working script from your lab mate, and workshop 1 from HPC 200 is a sample for your calculation to the current working directory which you plan to edit. So this is a typical scenario when you are working in a lab or doing some sample problems. You want to copy something and then you want to work with that file. So you cannot read and write something that's in somebody else's directories because they own it. So you would wish to copy it to your own local directory and then go from there. So here's what we can do. We can do CP and then we do home HPC 200 workshop 1 file 1. So notice we're using the absolute path here. And then we use the dot to indicate my current working directory. So that will copy that file to your current location. There's also some other conventions you should be aware of. The tilde symbol is the symbol for your home directory. The tilde path will point to your home directory when you are logged in as you, but you can't expect that somebody else would use the tilde to point to your home directory. It will point to their respective home directory. If you use a tilde in the path in a script to point to, for example, tilde/bin, then and you share your script with someone else, then they use the script and it will look, and they can look in their bin to use it if they copy it into their local bin. So you can, so tilde/bin is useful as a convention because we usually store our scripts that we wish to share with people in the tilde/bin. So if I want to share something with my lab members, for example, I would store it in my tilde/bin so that they will know where to look for it. And then if you wish to share some of your scripts with somebody, you can use tilde/bin in your directory. So then I would know if I want to use yours and your name, your username is HP199, then I would know to go to HP199/bin because it'll be in your respective bin. So the idea is your bin should be inside of your home directory so that we all know where to find it. A few more things about the bin. Bin actually stands for binary and indicates an executable code, which is binary format, otherwise known as machine language rather than a text file. It is a bit of a holdover since a number of modern programming languages like Python use an interpreter, and so it's not actually going to be compiled machine code and you could open it up and read it. But it is a folder that's understood to hold your scripts and executable codes. It's generally placed in the user's home directory, as we've mentioned, and there are bins for software or of shared programs on the cluster. So for example, we have this path right here. This is a bin for Amber, and so by convention we know that the bin is where to look if we need to go find some executable code. And so it's very convenient to have that convention in place. It's an ordinary directory that you create and it has no magic associated with it. Using bin does not in any way attribute any new functionality to it or anything like that. It is just a convention for storing the code. All right, so now that you know a little bit about the directory trees and know how to traverse the directory trees, you know how to copy, you know some of the standard notations that we would be interested in using, let us talk about the text editors themselves, which would allow you then to use the files that we have just talked about finding. So editing text files in Linux would require to have some kind of program to do so. So in Windows, you might use the Microsoft Office products, you might use Notepad, Microsoft Word, things from the Office suite, and so on. And so then the question is, well, what can I use if I'm on Linux? Because a lot of these programs don't actually run there. So the answer is Vi, Vim, Emacs are some of the popular choices you might wish to use in Linux. Why would you use a text editor in Linux? So the same reasons why you'd use a text editor in any operating system. There are a number of common tasks that you would want to do read, write, or look at the text of a file. So maybe you want to write an input script. Maybe you want to write some scripts from scratch to do some tasks. You need to write some code. Maybe you want to write some notes about your calculations, especially if you have lots of trials and need to keep track of, just your thoughts, your notes, whatever. Also to view the output log file of the calculation, and you may also need to check some error files. Linux text editors, by the way, are not ideal for word processing. You should really invest in different kinds of programs for doing that. However, they are quite useful for doing basic editing functions that we have mentioned. So with so many choices, how do you know which one should be for you? Well, there's some important points about each of them. They all have their strengths and weaknesses. And it does tend to be that there are some top choices that people tend to make. So I'll try to guide you and help you figure out which one is best for you. But if you don't have any experience with any text editors, my suggestion is to try out all of them in a brief way, and you will probably quickly realize which one is your preferred style. So let's start off with a comparison of Pico and VI. So Pico is one of the simplest text editors. It's very easy to use. It has very few commands. It's intuitive, but of course, because it has so few commands, it does have limited functionality. Both Pico and VI are relatively small and are command driven. VI is powerful, has powerful functionality, but it does have a substantial learning curve because you need to memorize a number of keystrokes. And if you're not so good at memorizing those things, then this may not be the one that is for you. However, if you do put the effort in to learn it, there are substantial gains to be made. Right, VI and Vim, in fact, are actually more or less merged into a single program these days. It used to be that disk space was an issue, and so Vim, being a little bit larger, was reserved for larger systems, but this is not really a problem anymore. So in fact, if you try to use VI on the HPC here, in fact, you will get Vim because it's basically, there's a pointer to actually run Vim. So VI is basically shorter, simpler. It's a smaller VI is smaller than Vim. Both of them are pretty ubiquitous on all Linux systems of all flavors. It's an intuitive command language. I think that's a bit of a debatable point, but there has been an effort made to make it at least be somewhat intuitive to learn. There is, in my opinion, a substantial learning curve for both of them, and it is pretty powerful once you've put the effort into learning it. So with Vim, you can expect that there are some features that are available, and as mentioned, since we don't have VI, basically even if you run VI, you will have these things: the auto completion, spell check, comparison between files, capability to merge documents. You can use Unicode. Vim diff is a tool that will compare two files and tell you what's different. They support regular expressions, which means completion with patterns such as it starts with ABC and then you can put a star to match anything. It also is useful for writing scripts. There are plugins available. A GUI is available. There is also some syntax highlighting and other edits that may be useful for you as you are using this script. Now, this to me is probably the most meaningful comparison to make, and that's from Vim and Emacs. In my experience, people usually tend to fall either in the Vim camp or in the Emacs camp as their favorite text editor to use. So Vim, as we've just talked about, is useful for a number of things. It is useful for occasional edits. It's widely installed. However, the issues with it is that it does have that learning curve to get started, because you need to know what all the commands are. And if you don't know what they are, you may feel stuck when you try to use it. Emacs also has a steep learning curve, but it is not really so command driven, and it's much more intuitive in terms of how you can actually type and enter the data. We'll take a look shortly at how one actually gets started with using these, and I think you'll see that Emacs is probably the more familiar, especially for Windows and Mac users, in terms of you just open the document and you start editing. Whereas Vim, you need to keep track of what mode you're in, and you're not automatically simply going to be able to just edit your text. Emacs is quite a bit larger, so it takes up a lot of disk space. That's partly because of the interface it's making for you. It does run slower, although if you're using this simply just to edit some files, it's pretty unlikely that that's going to be an issue for you. It is pretty easy to get started because it's very intuitive and very similar to word processing that you're used to. Although, again, I wouldn't recommend it for word processing, but it's more like a word processor. Or you could say it's more like a shell, I suppose, whereas Vim is more complicated, as you'll see. These aren't the only choices that you have available. There are a number of other choices for text editors out there. I just listed some samples of some of the ones you may have heard of, or maybe are interested in getting and working with. The ones that we have on the cluster I've highlighted in red, and the ones that we will be covering today are bolded in red. So let's take a look at the highlights of the different editors. This is a preview of working with Pico. This is the simplest of the editors we'll take a look at today. I'm just showing you the interface, and this is pretty much all there is to it. All of the available commands are displayed down at the bottom because there really aren't that many. Sometimes you need to switch to the next screen because you might get into a window where there's more options, but it's pretty easy to figure out how to do all of this. The little arrow symbol here just means you type the control before that letter, and all the commands are lowercase letter, even though they're shown in the capitals. And other than that, basically you can just type in here as you would normally type. So these are the Pico commands. There is the get help, the cancel for saving, write out, which means like save or save as. Control J is for auto wrapping the text and justifying it. Control R is for reading files. Control Y is previous page. V is next. Control K is for cutting the text, because Control C is already used for cancel, so K is for cutting. U is for uncut, that is paste. And Control C is for current position. This reports the current cursor position in the file when you're not in save mode. And Control T goes to the spell checker. This actually has to be installed, and you may encounter machines that do not have the spell checker actually installed. So that's pretty much it for Pico. It is great to know because a lot of places do have it installed, and if you do not want to learn the complexities of Vim and Emacs is not installed, which you may encounter, it's great to be able to get your work done using Pico instead. All right, so let's move on to Vim. Vim has 4 modes, and this is part of what makes it more complicated to work with, that you need to pay attention to which mode you are in to know which menu options are going to be working. Normal mode, this is your default mode. You can navigate around the text using the arrow keys, and escape will bring you to this mode from any other mode. However, you don't type in normal mode. You need to choose one of the other modes, such as insert. So this is the mode you would most commonly use to do writing. So it would insert at the cursor, and you can then type your text. The visual, this is for the text selection. So one might, for example, begin in the normal mode. Then you may make a selection in the visual mode and then go to the insert mode in order to actually write your text in. There's also the command line, and this allows you to call Vim commands. So in the normal mode, these are the options that are available. So the keystroke commands are it's driven by the keystroke. So you need to learn the keystrokes in order to do this. So the navigational keystrokes I have summarized over here. So H, J, K, and L may seem a little bit arbitrary, but if you look at the layout on the keyboard, it may make a little bit more sense to you about how they are indicating how to move around in the text. We can also do a number of moves to the beginning and end of the lines, to the beginning and end of words. We can move forward and backward. You may wish to use first non-blank character, end of line, and then we can also go to the command. So for example, if you want to go to the 5th line, you would do -5G. So as you can see, this has quite a lot of options available, but that also means that there's a lot to remember. So this is what the insert mode looks like. We can use insert mode to enter the text, and this is probably what would be most familiar to you. To initiate insert, you type the I or another insert command from the normal mode. You can then enter the text at various points relative to the cursor. You could then use another edit command. You need to use escape to return to normal mode and then enter insert mode with a new command. So you do have to just keep in mind where you are at. And when you're done typing your edit, you need to use the escape key. So this is some of the available insert commands. Insert at the cursor point, I lowercase, which is pretty much what you would be used to from normal word processing. A capital I will insert at the beginning of the line. Then we have various ways of appending, opening a blank line above or below, and also to escape, to exit out of the insert mode. So that just gives you a sense of what it's like to work with Vim. Very powerful once you've memorized the keystrokes. There is some effort needed in order to get up and running with that, though. This is to show you what Emacs looks like. Most text editing happens in just a single mode instead of several modes. The commands are used for special text editing. The column addition and deletion, which are some of the features that are unique to Emacs. You can use, it's configurable for editing programs and or script files with auto indent, color coding, and other such features, which makes it really nice. So if you're writing in a particular programming language, just like another interface you may use, it will color code all of these things up for you. It also has search and replace available to you. So you can see that it looks pretty simple, and basically you just put the cursor where you want to type and you start typing as you would expect. All right, so we have some exercises for you to practice with the various types of the text editors. The learning objectives for these are to review the basic concepts for working with the files and directories that we've talked about, that directory tree, becoming familiar with 3 popular text editors most often used, Pico, Vim, and Emacs. Again, my recommendation to you is to just test out all 3 to see how they feel, and then you will likely settle on one as your favorite. Truthfully, I think it's a good idea to just learn Pico because there's so little to learn, and then you'll always have something you can fall back on, because pretty much Pico and Vim are going to be installed on any Unix type system that you may encounter, whereas Emacs, you may find you actually need to install it. So if you happen to get stuck on a system that doesn't have Emacs, you don't want to be in the unfortunate situation of not being able to edit your text file. So you would be likely to be able to go to Pico instead if you are not going to become a Vim expert. So I would say you want to do, you would just want to learn Pico and then probably choose between Vim and Emacs as your focus as you move forward with learning a text editor in more detail. So you will edit the text files in multiple editors, making use of some helpful features that each has available. So I've tried to point out the things that are really useful. So for example, Emacs has the advantage that you can edit in columns of text, which is incredibly helpful if you need to edit some data files, like maybe you need to delete a column of text. So instead of, deleting and then moving your cursor to the next line and deleting that one, you can actually do a block delete. Which is unique to Emacs and incredibly helpful for that sort of a situation. So at the end of this, you'll be able to complete the following basic tasks for HPC. You'll be able to read and write plain text files, capture and parse output to a file, write a simple program in an editor and execute it, write and execute a bash script to automate tasks. There'll be more about bash next week, but you can learn how to do the bash scripts so that then next time you'll be able to focus more on actually learning how to program in the bash as opposed to just working with the basic scripts, which we'll handle today, and use features of editors to facilitate the automation of computational tasks. A quick word about Unix on Mac. Did you know that there's a penguin inside your Mac? So the penguin is the symbol for the Linux machines. And in fact, on Mac OS X systems, there is actually a terminal, and Mac is in this generation and forward is based on the Linux operating system. So you can use almost all of the commands you can use on a Unix machine on your Mac machines. You can get your terminal to do applications, utilities, and terminal, and that will bring up this terminal, which looks like this. And then all the things that we're showing you in the tutorial, you can also do on your Mac. So then in summary, on day one, we had a first look at HPC. Today, we've talked about working on the cluster with the text editors, and next time we will do the bash scripting. We have learned about the directory tree. We have learned some essential Unix commands related particularly to the directory tree. And we have also taken a look at 3 popular editors, Emacs, VI, Pico, and Emacs, Pico, and VI, which is really just Vim. All right, well, thank you so much for joining us today. I hope you have found this to be informative, and I hope that you will join us next time to learn more about working in the high-performance computing environment. For those who are interested, we do have the tutorial on this. We also have the slides available, which includes this graphical cheat sheet for the Vim. And this is where you can find today's workshop materials. Thanks so much, and we hope to see you next time.